Welcome to Phase 3 of our AI Robotics Behavioral Project, Multi-Agents, by John, David, and Eric. For this project, we built on top of our previous work from Phase 2 to automate a single UAV to block a hallway. We adapted the behavioral schema from that project to work independently on any number of UAVs working in an area. The UAVs each have an instance of the behavior on them, and the number of UAVs available will not matter, but of course will be limited by the size of the area they are operating in. Previously, we had sensor data for the location of the UAV coming from a stub, taking the place of a Hakoyo sensor. But with multiple agents possible, we had to change things around a little bit. Our Hakoyo stub gives the instance of each UAV its own location only, and is assumed it can tell the difference if there are multiple agents. This solves the problem of distinguishing between UAVs in a single plane. There is no global distinction between UAVs for each agent. An additional stub provides sensor data on other agents that's specific to each instance of the UAVs. Because of this, no global knowledge is needed of any other agents in the area, and they can come and go as necessary. We refactored the previous project to no longer use subsumption. In addition to including a new avoid UAV with the avoid behavior, we now use innate releasing mechanisms to activate each behavior. These are then all summed into one vector output for coordination. Here's our overall architecture. Our new methods allow for UAV A to detect any set of other UAVs. For each other UAV, let's say B, it will identify the set of crowds closer to B than to itself, then ignore the crowd in that set closest to the block line. This design will prevent multiple UAVs from interfering with each other and trying to block the same crowd. During this phase of testing, we're spawning 5 crowds every 5 seconds, and you'll notice a bit of a jump in the UAVs. This is because they receive a fairly large instantaneous velocity. While not completely realistic, it is highly effective. This particular simulation here ran for over 12 hours. Here you'll see a visual representation of the vectors the agents are using. The red lines from the UAVs are noticed but ignored objects, while the green lines are the vectors they're currently acting on. After changing the velocity increase to simulate more realistic hardware, you don't see as much of a jump, but more targets are also missed. While this is somewhat more realistic for simulation, we're still not convinced it's an extremely close match to the actual hardware. With changes to the crowd's fear levels of the agents and the velocity caps, we're confident that the 70% blocking you see here is worse than what you would actually see in a real-world implementation. Hopefully you've also noticed the agent's ability to pass over and under each other without collisions. We thought that was a nice added bonus to this simulation. These results and more are recorded in our testing plan and technical reference manual. We hope you've enjoyed this demo. Thank you for your time.